for example 7, looking at this, again, using the criteria that I used to say, how am I going to solve this? I've got a system of equations. I've got the x's lined up, I've got the y's lined up, both on the left side of the equal sign. I got the numbers lined up on the right side of the equal sign. All the coefficients are not 1. So elimination is going to be easier than substitution for this problem. So it doesn't specify what to use, but I'm using elimination because, again, no coefficients of 1. And again, it's already set up like this. Now, if I see a problem where there's no coefficients of 1, it's not set up like this, it's just a matter of moving things around. Like if it said 3x equals 7 minus 2y, just move the 2y over, so now they all line up. So you're allowed to rearrange things if you want to. But again, if I'm going to use elimination, my checklist for using elimination is the first object would both have to be something about x, the second object would both have to be something about y, and they should be equal to some number. The number could be 0, 7, negative 2, 15, 20-thirds, whatever it is. If it was 15, 20-thirds, I'm going to want to modify things a little bit. But that's the structure we're looking for. And once I see that I have to decide, I want to get rid of x or y, it doesn't matter which one I decide to get rid of. I'm going to let Kevin pick today. Kevin, you want to get rid of x or y? X. All right, so Kevin wants to get rid of x. So if we focus on the x's here, and I want to get rid of x, I need to make them both the same number through multiplication. So what can I make both of them become? 12, right? 3 times 4 is 12, 4 times 3 is 12. The other required criteria is they have to be opposite signs. So one of them has to be negative. Currently they're the same sign. So when I do my multiplication, I'm going to take the top equation, multiply it times a positive 4 to get positive 12x on the top. I'm going to take the bottom equation, multiply by negative 3 to get negative 12x on the bottom. I could go negative 4, positive 3, whichever. It doesn't matter which one's negative. Just make sure one of them is. Okay, so 4 times 3x makes the positive 12x that I wanted to get. That's what I want. The consequence is everything gets quadrupled. So positive 2y times positive 4 makes positive 8y. Positive 7 times 4 makes positive 28. So everything on top gets quadrupled. 3 times 4, 2y times 4, 7 times 4. On the bottom, everything's getting tripled, but negative tripled. So negative 3 times positive 4x makes negative 12x. What I wanted to happen, the consequence is everything has to change. Negative 3 times negative 3y makes positive 9y. Negative 3 times negative 2 makes positive 6. Be careful in the multiplication process that you are mentally focusing on the signs as you go through, positive, negative, whatever. Make sure those things are popping in your brain so you get the right sign on each product. Okay? The goal of that process was for these two objects, x, since Kevin decided x needs to go away, was for those to be opposites, which they are. So, once we achieve opposites, now it's just add up this column, add up this column, add up this column, you get what you get. So, when you add this column, the 12x minus 12x opposites cancel, eliminating x from the problem. Now it doesn't exist anymore for this part of the problem. 8y plus 9y is 17y. Both signs are positive, so I added. 9 is positive, so it's positive. 28 and 6, both positive, I added, get 34. And if 17y equals 34, we divide both sides by 17 and end up getting y equals 2. As long as x or y that you find in this step is a pleasant answer like 2 or 5 or negative 1 or something like that, substitution is probably the easiest way to find the other answer. So I go back to one of my original problems, doesn't matter which one, before I started messing with them. So I'm looking up here. Let's say I go to this top equation here. It says 3x plus 2y equals 7. So I take that equation, write 3x plus 2y equals 7. Instead of writing y, though, I'm going to write y equals 2. I'm going to put a 2 there. Just simply substituting its known value in once we figure out what its known value is. 3x plus 4 equals 7. 2 times 2 is 4. Now it's just a basic algebra problem. Move the constant over to the other side. 3x left on the left is equal to 3 on the right. Divide both sides by 3 to get rid of the coefficient. X equals 1. And once we know both x and y, x goes first, y goes second. Doesn't matter what order you find them in, you always put x first, y second in your ordered pair. As stated yesterday, in the event that you get some unpleasant answer here, you get y equals 947 853 or something like that, right? First of all, you're probably wrong. But if you're right with that answer, we eliminated x to find y, right? So if I go back up here and eliminate y to find x, that'd be the easier way to find x in that scenario. So multiply by 3 to get 6y, by 2 to get negative 6y, everything else gets tripled and doubled, and then you'll get an answer very similar to this with the same amount of work. So again, if you get a pleasant answer, substitution is very easy to do. If you get an unpleasant answer, I just go eliminate the other variable to find the other answer at that point. So that's just a advanced knowledge point of view there. So.